very much for being here. I appreciate your time. So my name's Paul Durzan. I'm in our HP's Converged Infrastructure group. And we're actually responsible for multiple things. We're responsible for putting together solutions to make people's lives easier. So I'll talk about that. We're responsible for software. And we view software as being very important in the whole story, because what it does, in our opinion, when you bring it to the infrastructure layer, is it provides a level of intelligence and abstraction. And we're going to talk about how that's going to help lead us to our future vision that we call composable infrastructure. So I'll talk about composable infrastructure, and I'll talk about software. So we just had recently our big event, and we talked a lot about what we call the new style of business, right? We know that there's a fundamental shift going on in IT. The shift isn't 100%, and the way we view it is when you look at IT mostly today, it's really a support function, essentially. It's, as someone said, it's kind of like a warehouse, right? You have space and you rent space to people who need applications, and you run that and you run it well. And there's a bunch of things you need to do to run it well. Number one, you need to make sure your environment is as stable as possible. That typically means as few changes as possible, because we all know that making changes is fairly difficult. It also means that when you make a change, you have to involve a lot of people, because there's people typically, depending on how large you are, responsible for compute, network storage, applications, security, etc. So you have to have a lot of process if you want to make a change. You try to make as few changes as possible, and typically you're using someone else's application. What we're seeing in companies that are making money off of IT, where IT actually shifts focus from just being a support to actually enabling the business in terms of revenue, is typically applications are developed in-house, or at least specifically for that company itself. It tends to be very software-based, so you want to make sure that you start to bring your redundancy into your software, your intelligence into your software, and you want to have what we'll call continuous deployment. You want to be able to change very fast. So essentially it becomes the polar opposite of traditional business. On one hand, in the new style, you're changing quickly, you're very dynamic, and in the old style, you tend to be a lot more static. So as companies try to move from one to the other, and we're starting to see that transition happen, inevitably there's a conflict, because you have to support the current business. You can't stop it. It's a critical part of the company, and it requires a lot of resources, a lot of resource for security, a lot of resources for provisioning, to make your updates, just to do routine maintenance. And it becomes difficult really to start to drive to this new style, this new vision. So what our goal is, if we go back here, is really to take that gray line and enable as smooth of a transition as possible. Because what we found is that if we can help design for the new style of business, we actually make traditional business a lot more efficient. Because all the problems in traditional business about being static, about being difficult to change things, can get solved. So that's fundamentally the goal. So when you look at our strategy and what we're trying to do in the Converged Data Center Infrastructure group, it's really pretty simple. Number one, it's to simplify lifecycle management. Number two, it's to accelerate time to service, so make sure that applications get running as quickly as possible. And sorry, it appears that the font didn't quite work on this one. Number three, it's to enable infrastructure automation, so we think infrastructure automation helps the first two. And then it's to provide a comprehensive level of services. We know services are really important. We know support's really important to what you do. And so our goal is to make that as easy and as comprehensive as possible. So looking at on the first part, we have HP OneView, and we just announced HP OneView 2.0, which is going to become available shortly. So HP OneView, in my mind, does essentially two things. Number one, it helps take care of your infrastructure, helps monitor your infrastructure, helps you find things very quickly, gives very easy and clear relations through how we map things together. But it also does this level of abstraction. And what this level of abstraction is you can create the personality of the infrastructure in a template. We call it a template or a profile. And you can apply that profile to, for example, a compute node. And that profile will fully define the compute node. It'll put the right firmware on that compute node, the right BIOS settings on the compute node, the right network settings, the right storage network settings if you're using Fiber Channel, for example. And so now what you've done is you've abstracted the personality of the infrastructure into this software component that you can go and very easily lay down on a piece of bare metal and give that bare metal the personality. And that really becomes step one of what you see our future vision will be, and I'll talk about that. So some of the interesting things we're going to be doing in this OneView 2.0, again, that's coming out shortly, is having the ability to start to make firmware management much easier. So what you can do, for example, is you can create a master template for a cluster. Let's say you're deploying a VM cluster. You create the personality of every compute node on that cluster, and you can chain them to this one master template. Now if I need to upgrade my firmware, what I can do is I can upgrade my master template, and that upgrade will roll through all the templates associated with that master template. So essentially, that makes life a lot easier because now I can test that one template that I do the upgrade for, make sure it works, do the change, and all I do is change one thing and it'll roll through the rest of the infrastructure. So that becomes very easy to do, a very nice way to do it. We also understand that not everyone wants things to be done automatically, so you can actually cut that link and you can do it manually. It's essentially your choice, but if you're comfortable with having that level of automation, you can do that. We've also brought together drivers and firmware. So typically what you see in the industry is that the drivers are kept separate from these profiles. And so when you create profiles, you have to go to one place to get your drivers, you go one place to get your profiles, and you have to bring them together. We've put them together into one tool, so they're all in one place and you can do everything from one place. That's philosophy that you'll see us have going forward. The other thing we've done with OneView 2.0 is we've brought in HP Virtualization Performance Viewer. The nice thing about that is that starts to give you a view of your cluster. So what you can do now is not only look at your individual infrastructure components, but you can take a cluster view. So now I can go and I can look at all the clusters I have, if I'm a VMware company, all the VM clusters I have. I can break them down and I can start to do what-if analyses. I can say, okay, this cluster looks like it's getting full. What happens if I bring in 2 more compute nodes? How does that impact it? Or if I have to do some vMotions because I want to do rolling upgrades, what would that look like? So you can do scenarios in a simulator offline, make sure it works. So when you come online to actually do what you have to do, you know it works and it'll work. So that's essentially how we view OneView, and I'm going to start to talk a lot more about OneView in the end as we look at our vision to what we think the infrastructure should be. So we have a couple of keystone products. One of them is what we call the CS700, and the goal of the CS700 is really to bring together and make integration a lot easier. So for example, if you're deploying a typical system today, you're going to buy your compute, you're going to integrate it together, get it set up. You're going to buy your network, integrate it, get it set up. You're going to buy your storage, integrate it, set it up. You're going to integrate everything together. You're going to test your application across those. When it doesn't work, you're going to try to fix everything. If it really doesn't work, then you're going to call your networking company because you may think it's a networking issue. They're going to tell you, no, it's my storage. You're going to call your storage vendor. They're going to say, no, it's your server. You're going to call your server vendor. They're going to tell you it's your hypervisor. And then you're going to call your hypervisor company, and they're going to tell you, no, it's your storage, right? So you go in this big circle, lots of numbers to call, very difficult to figure out what's happening. The concept of converged system is to bring this all together into a single system. And when you do that, what we want to do is we want to do a few things. Number one, we're going to factory integrate this, so you don't have to wire these things together. You can just roll it into your data center or wherever you keep your IT infrastructure. Roll it in, plug it in. It's already wired for you. Number two, we're going to validate everything together. We're going to make sure it actually works together, so you don't have to make sure it works together. Number three, we're going to validate the firmware across the system and make sure that the networking and the compute and the storage firmware actually work together and act as one, so you don't have to do that. We're going to put software-defined management across it, so it's very easy, very malleable. And then, really importantly, and I'll talk about this later, we're going to give you we're going to give you essentially world-class services. So what we're going to do is we're going to assign a technical account manager to every customer who buys one of these, who is going to be reviewing what is happening in your environment. We're going to run compliance checks on your environment twice a year to make sure everything is in compliance. We're going to give you a single support center, a single phone number to call across all of these components. So you call one place, whether it's compute, network storage, or even your hypervisor, even your ISV. So we're going to give you end-to-end support from the infrastructure all the way through that application. One number to call. So that's a concept behind what we're doing with converged systems. The CS700 is essentially what I'll call a converged system, really based for general purpose workloads. So it comprises of the C7000 or the HP Blade system with 3PAR, and networking, you have a choice of HP networking and Cisco networking. What's new and what we've done recently on this one is we're also taking these systems and integrating the application into it. So we have reference architecture for HP Cloud System 9, for those of you familiar with HP Cloud System, with Microsoft Unified Communications and Collaborations, with VMware vCenter DR, built with 3PAR storage replication, and with virtual desktop. So these are some of the new reference architectures we've done, but again, the goal here is to optimize this infrastructure for the application, so when it leaves the factory and it comes into your environment, it's exactly what you need it to be. So that's a converged system 700. We also have some really nice converged systems for HANA, for those of you looking at that. And probably the most notable one we have is a converged system 900. This is a pretty amazing product. So what we did is we went to our Unix heritage and we applied it to x86. So it's the x86 server, but you can get 12 terabyte in-memory footprints. You can get up to 96 terabytes in a single system, because what we do is we have the ability to start to bring together our memory to have cohesiveness across our coherency across our memory. And because we know that that's a lot of data in your memory, we put a whole bunch of availability features that we took from the Unix world. So we have self-healing. We proactively monitor for errors. If you have a firmware error, we have the ability to isolate it so it doesn't impact your data. So, and an extensive amount of memory protection. So the goal here is to give you a system that you can put something like a SAP database in your memory, have a very large database, and have it be highly protected. What people have found is that people who've been running this in SAP, number one, they get very good uptime. So, in the 9.9999 or 9.99 plus. And they also end up saving a lot of money because it becomes a single system that, again, is always up, and you can get a lot of your data into that in-memory database. So that's what we're doing. Also, SAP is coming out with TDI offerings. So the Converged System 900 is a single system, but it'll also become, we're essentially breaking it apart so you can buy it modularly and have it part of SAP TDI offerings. Okay, what we also announced in June is a partnership with Arista, and actually this has already been pretty successful with us. We already have several joint deals together that have been completed. And so we're working with Arista to do joint reference architectures and make sure that, as our customers who are using Arista want to integrate Arista into something like a converged system, or with HP, we guarantee they work together. And you'll see us continue to build out that relationship as we go forward. All right, so let's talk about hyperconvergence. So on Tuesday, we announced a new hyperconverged product, the HP Converged System 250 hyperconverged system. And really, the philosophy of this product is about, we want to make sure that, we know time to value is really important. So it's about maximizing this. With this system, you can go from power to provisioning in 15 minutes, from 1 to 4 systems. It takes 15 minutes to provision, and I'll talk more about that. It comes with factory integrated ESX. We have the ability to integrate ESX at the factory, so you don't have to worry about doing that yourself. And since most customers somewhere have HP in their world, there's really no need to retrain your staff. You have the ability to use HP management just as you always have been. These systems are going to be very cost effective. We have very, very competitive entry-level price points. And of course, the great thing about HP is you get world-class, right? We have world-class leading servers, leading server vendor. We have world-class services and support. Any city, any country, anywhere in the world, and you'll find HP there and ready to help you. So when you look at what we're doing, we're really targeting 3 areas with this product offering: medium-sized businesses, enterprise, remote office, branch office, and line of business. And so again, like I said, you can scale up to 4 appliances in 15 minutes. You have the ability to do centralized management. So again, if you're in a branch environment, you can manage these products from one centralized place across dispersed geographical places. And then for the line of business, we have the ability to make sure that You have, there's the ability to obviously support things like VDI, desktops, your R&D environment, so your test dev environment, and integration. It's built on the HP Gen 9 Apollo 2500 hardware. So it's essentially optimized compute with software-defined storage on it. Again, the goal, and you'll keep on hearing this, 15 minutes from the time you get it to installation. Same experience, whether you're on the first or fourth appliance, and easy to configure with vSphere and Store Virtual. And of course, we want to make sure it scales, so you can scale up to 8 appliances, which is 32 servers. Linear scalability as you add more. Full VMSC support. It's customer installable, so you can actually install it yourself, very easy. And we have built-in availability in DR packs, which are coming in a future release. And so a key part of this is what we call Instant On. Instant On is what allows you to deploy this quickly. Simply, there's about 5 minutes of keyboard work because you're going to have to log in, authenticate yourself. You're going to have to enter some networking. But all in all, it's a relatively easy and painless way to deploy. So that's our HP 2500 converged system. So you can see we're pretty broad. Again, systems around virtualization, systems around in-memory database, systems around hyperconvergence, software that allows you to monitor and provision your servers. And so this becomes part of a bigger story, and I'm going to get into the bigger story in a second, but I just wanted to cover off this here, where now what you have is you have HP OneView, which I talked about earlier, stretching across the infrastructure, becoming that point of abstraction for the infrastructure. So I have infrastructure with no personalities, and OneView can now apply the personality of the infrastructure onto that infrastructure. And our goal here is to start to integrate at different levels. So OneView, for example, already integrates very nicely with vCenter. In vCenter, you can go and actually create your server cluster, create your volumes, and provision your VMs all from one tool. Typically, the way that's done today is you go into a server tool, you provision your servers, you bring your servers into VMware, you have a storage person go into the storage arrays, provision the volumes, bring those into vCenter, and then your virtualization admin goes in and creates the VMs on what has been brought in by those other people. Again, here with our integration, you can go into vCenter, create those clusters from vCenter, create those volumes from vCenter, create those VMs from vCenter. So we're integrating into that hypervisor level, but we also are going to be integrating into the higher construct levels, things like Healy and Chef Puppet, and I'm going to talk about those as we talk about composable infrastructure because they're more closely related. But this is how we start to see the big picture around automation. And finally, like I said, we've spent a lot of time getting services right for these products. So again, we know that integrating products is very difficult. Validating products is very difficult. We know that getting firmware talking across products is very difficult, and troubleshooting that's very difficult. So we created these services. Again, it's a place that comes in. We will view our system as a system. So we don't view 3PAR and Blade system and HP networking as separate. We view them as one system. We'll troubleshoot across that system. We'll release firmware patches across that system. When there's new firmware updates, we release it across the system, not in individual things. So you can upgrade the system as one number to call, as I said earlier. So again, we view it as a system, we manage it as a system, so you can view it as a system and not have to worry about all the difficulties of making the pieces work together. Okay, and so that's really fundamentally what converged system is about today, right now. It's about being fast, so being able to reduce your time and bring your product to, or bring your applications on as quickly as possible. It's about being simple, so you don't have to do all the hard work, take all the kind of meaningless, boring time trying to set things up together that should work, because we make sure it works for you, and it's about being efficient. So the path really today that we're saying is OneView, and you're going to see, I'm going to start talking about composable infrastructure. OneView is a really important part of this. OneView is a link from today to tomorrow. And so again, we encourage people to look at OneView if you're not looking at OneView right now. Engage with HP with a proof of concept. If you don't already have converged systems or you haven't looked at them, we'll be happy to come out, talk to you about them, give you a proof of concept, and help you understand, especially if you're taking this journey from today to tomorrow. If you know your IT has to transform, we have a lot of experience doing that, and we can help you. Okay, so let's talk about composable infrastructure and what we think the future of infrastructure is about. So right now, I talked about three key things: software-defined management, which was through HP OneView, converged system, HP Blade system, and then hyper-converged. And we believe that all of these are going to essentially come together into the future into something that we call composable infrastructure. So what composable infrastructure is about is creating an infrastructure that can be optimized for an application outside of the bounds of the physical infrastructure itself. So what that means is we want to go and we want to create pools of resources, pools of compute, pools of network, pools of storage. We actually don't really care where, for example, those disks come from. We just want to know those disks exist somewhere and we can assign them somewhere. We want to make sure that these pools of resources work across physical, virtual, and containers. We don't think the world is just going to be virtualized, because we know there's customers still with physical. And we know containers are up and coming. So for those of you who haven't explored containers, developers love containers because they go and they can develop on their laptop in a container. And when they put it in their test environment, they don't have to change anything. It works the exact same way it worked on their laptop. Today, it's not that way. They develop on their laptop, they put it in test environment. The test environment is invariably different than what's on their laptop. Things break and they spend all their time troubleshooting. So developers love containers, and as we move to this new style of business, we see developers becoming more and more powerful, so to speak, because they're starting to dictate what they need. So we think containers are going to be very important, and we're doing a lot of work with container companies. We know virtual is a big part of everyone's organization, so we're going to, again, accommodate virtual, but we also know physical is still there, and we'll accommodate physical. So all three of those is important. And the concept here is, all right, I need to accommodate any type of essentially compute, pooling compute. But I also want to do the same for storage. I don't really want to care if my application needs block, file, or object storage. And I especially don't want different types of, or different pieces of infrastructure to accommodate different storage. What I really want is right before runtime, I want to be able to define my storage to be either object, file, or block. Just like right before runtime, I want to go and tell my compute pool what it should be. So the goal here is to allow, right before runtime, you to define what your infrastructure is going to be for that application. So you create these pools of resources. The way they're going to be created is through disaggregation. So again, today, when you look at today's environment, a rack mount server may have, let's just say randomly, 16 disks. And if you're in an environment, in your test environment, let's say your application needs 12 disks, and it's running fine, and you put it into production, suddenly the amount of data it's uptaking increases, because sometimes they're different, right? And you suddenly need 18 disks. Well, now to get those other 2 disks, you either need a whole new form factor, and you have to go through the process again, or you just buy another server for 2 more disks. And now you're spending money on compute, network, and memory for disks that you don't need. Our goal is let's disaggregate disk and other resources, so we don't really care where the disks sit. Whether the disk is sitting in server 1, 2, or 3, we don't care. If server 1 needs disk, server 3 has that disk, we can assign those disks from server 3 to server 1 because it's a pool of resources. So disaggregation becomes very important because it allows us to create that pool of resources. Once you've disaggregated and created those pools of resources, you actually have to define them for the application. So I'm going to have an application that needs a certain amount of compute, memory, and storage. So I'm going to use my software intelligence to program the infrastructure to meet the needs for that application. The other thing we think is important is what we call a unified API. So if you think about programming today's environment, you're probably programming, if you're trying to automate your environment, you're probably writing script to compute vendors, storage vendors, network vendors, hypervisor vendors, a whole bunch of different people that you're trying to automate in the data center. What we want to do is we want to consolidate all that, have one API going northbound for your whole infrastructure, especially as the world moves towards DevOps, which we see that trend happening. They have a workflow, and you want that workflow to reach down to one API to program the infrastructure. So the goal of the unified API is to have a single API that can program the full infrastructure, so you only have one language you have to program to and not multiple languages. And so the way this works, as I said, is we're going to have a set of hardware. That hardware is going to have multiple different form factors. It could have modular form factors. It could have rack mount form factors. It could have other form factors. When you have an application, what you're going to do is you're going to create a template for that application, put that template down on the infrastructure. That template is going to pull from those pools of resources what it needs for that application to create the footprint for that application. Again, because you don't really care about the physical boundaries of the servers anymore, what that means is you've now optimized your resources. You just use everything you have, and when you're out of it, you can buy more resources for that pool. And depending on what products you buy, you can start to get very modular and maybe buy just compute and CPU, or just buy disk, or just buy networking to increase the pool one way or another. If that application is done, you can put those resources back in the pool. And then if you bring another application and that application needs to flex or contract, again, you have the ability to add resources to what that application needs. So what you're seeing again is we're going to take these form factors, abstract the resources above those form factors into fluid pools, and create the exact footprint the application needs. What that means, in addition to being highly efficient and in addition to being real-time, it means now that you don't have to worry about what we'll call these stranded resources that aren't being used in the data center because the application doesn't need them, but you have no choice but to buy them. So when we think about composable infrastructure, the real goal here is to be able to run anything and store everything. Again, you don't need these multiple different form factors to optimize for the application, because the composable infrastructure can be defined in an optimal manner for that application. That'll allow you to deliver services faster, apps faster. It'll allow you to simplify lifecycle operations, because again, as you define real-time or right before runtime or even during runtime what that infrastructure should look like in an automated manner, you also have the ability to do the same with your lifecycle management and determine when you're going to upgrade things, how you're going to upgrade things, and do it in an automated fashion. And this is really the basis of infrastructure as code, right? So I don't who here has heard the term infrastructure as code out of curiosity? Has anyone? Okay. So I think it depends where you are. Some areas, I think this is going to become something we're going to hear going forward. I was just in Australia a couple months ago, and all anyone wanted to talk about was infrastructure as code, infrastructure as code, infrastructure as code. But I believe you're going to see composable become a term in the industry. We're already seeing other vendors starting to use it, and I think you're going to see infrastructure as code become important, because really in the end, that's what you want. You want your infrastructure to be code that you can program from a higher level construct. Now, all of this is part of a bigger story we have. So we know composable infrastructure is important, but we also know that a composable infrastructure, there needs to be a higher level of intelligence to compose that infrastructure, and there also needs to be a layer of management to manage that infrastructure across multiple places, right? So what we see is the need to hook this into these higher level constructs. So whether you're using Chef or Puppet or HP cloud system, you have the ability to program this infrastructure and integrate it. So as we go forward over time, what we'll be doing is we'll be integrating all the layers together so you get a single experience. And for the companies that are large enough and they have their own developers and they're moving towards the DevOps process, we'll even integrate that in. So it becomes an end-to-end integrated solution where all the pieces and the parts work together, and yet it'll also be modular. So if you only want composable infrastructure, you can buy that. If you only want our developer platforms, you can buy that. If you only want our management and operation platforms, you can buy that. Or if you want the first two and the middle one you want to be someone else, you can do that. So the goal is to be open, to be modular, to allow the various pieces to be interchanged, but the goal is also to make sure that from an end-to-end perspective, all the way from the day the developer touches that application to when that application gets to the infrastructure, to the management of the infrastructure underneath that application, it's all done with one integrated system. So that's the big picture vision. Now, to get there, we've already started to do some integrations. So in June, we, for example, announced what we call the Composable Infrastructure API, which is really the unified API, integrating into various higher level constructs. So is anyone using Chef out here? And is anyone using Chef here, out of curiosity? Okay, I don't see anyone using Chef. But this applies to Puppet, this applies to Ansible, this applies to OpenStack, and this applies to CSA. What you can now do is, because the personality of our infrastructure is in this template, this software template, you can put this template into these higher level construct tools. So I'll just use Chef as an example because it's an easy example to talk about. So typically what happens in Chef is it's an automation tool. And what you're going to do in that automation tool is you're going to tell what application to bring onto the infrastructure, but you're also going to program the infrastructure. So you're going to go into the tool and you're going to actually write in lines of code to configure the BIOS settings, to configure the firmware, to configure the VLANs, vSANs, et cetera, et cetera. That takes a long time. It's not really repeatable. And typically, the people using Chef are not the infrastructure people. They're application people. So they actually don't really know exactly what should be done with the infrastructure. And hopefully, they've synced with the infrastructure person. What OneView does is you're able to, instead of manually programming these automation tools to automate the provisioning of the infrastructure, you can actually put in a OneView driver. And so now when you go to deploy Chef, Chef reaches into OneView, tells OneView what template to deploy on the infrastructure. OneView deploys that template, it provisions the server, and voila, you're done. Another great example of this is how we integrate with HP CSA. So we have a insight control provisioning tool for OSs. We have OneView to provision the infrastructure. You can actually go into CSA, provision your infrastructure through OneView, provision your OS through our insight control tool, and provision your application through something like Chef or Puppet or even operation orchestration, and have one flow to deploy that end-to-end stack. So the goal here is to make things as easy as possible, as automated as possible. So as you move towards the software-defined infrastructure, you actually have the ability to software-define your infrastructure, software-define your image, and software-define your application, and create all of that from software without having to do a lot of manual work. So this is what Project Synergy is about. This is what we call Project Synergy. It's a multi-year roadmap. It does start today with OneView. So in the beginning, I said OneView was a continuity between today and tomorrow. And today, it starts with OneView, like I said, integrating into these higher level constructs to allow you to start to integrate the infrastructure. You'll see in phase 2, we'll start to bring out products that we call infrastructure as code. So these are products that you can again, that will create these pools of resources that you can define with software intelligence. Phase 3 will be getting to that 3-layer slide that I talked to you about, where we'll integrate from the application development all the way through the infrastructure, again, modularly, so you can use what pieces you want, but to give you end-to-end automation, management, and analytics. And then phase 4 is about starting to bring some of the machine product into the existing products. So you've probably heard about Memristor, right? We'll have the ability to start to bring, in photonics, we'll have the ability to start to bring some of these machine technologies into these phase 2 products, so they'll stretch out to the machine and become an easy transition to the machine. So that's what Project Synergy is about, multi-year roadmap. And really the goal here is to give people a path to the new style of business, right? Converged system optimizes your infrastructure, reduces your CapEx and your OpEx, makes things easier, makes things faster. When you bring in OneView, you have the ability to start to automate and create this software-defined environment, hook into these higher level constructs as you try to automate your data center. And then when you bring in composable infrastructure with Project Synergy, that becomes a way to get to this really fully defined software data center where we have these fluid pools of resources that can be defined and optimized for the application footprint. So that's how we see the future going forward. And again, the great thing is you'll notice that these arrows go from top to bottom, because again, what we found is as we optimize for the new style of business, we actually significantly increased the traditional style of business. When I talk to a lot of customers trying to do what I'll call a virtualization cloud, right? So it's just a VMware and they consider that a cloud. they keep on telling me it's really difficult for them because they know they can get their VMs up and running and they know they can move them, but what's really hard is getting that underlying infrastructure moving fast. They have to provision that infrastructure. If they're in a VMware cluster and they have to upgrade that infrastructure, very painful again, because typically what they're doing is they're manually provisioning every server to upgrade that infrastructure. So the application side is easier, but that underlying infrastructure is difficult. And as we move forward, we're going to solve for that underlying infrastructure. We're going to make it just like a VM, so you can move the personality of the infrastructure from place to place to place. You can upgrade it easily and automatically versus doing everything manually. So the goal is to allow you to be more efficient in the traditional world and yet have the ability when you need to move to the new style of business. And that is what we have for you. So thank you for your time. Appreciate it.
Thanks, Paul. Thanks, buddy.
Yep.
Appreciate it. Thank you.
Thank you.
All right. Every one of the speakers this morning has a table at the showcase, so when you go to lunch, make sure you stop by. We will break for lunch. If I could ask you to be back here at 1:30 for our final speaker of the two-day event, Dominic Orr from Aruba, which is now HP Aruba. So if you could be back here at 1:30, that'd be great. So thank you and have a nice lunch.